Welcome. Let's try to solve another Leetcode problem 2495, number of subarrays having even product. So for this problem, we are giving an array nums and we want to count the number of subarrays which have an even product. So for example, we're going to have 0, 1, 9, 6. So it is a 45, it is a 54, so it is a even. It is an even number for the product, and for 0 to 2 it is also, and also for others. Yeah. How can we solve this problem easily? Let's just check the numbers. So for example, we have 9, 6, 7, and 13. Yeah. Currently for this array we have an even number, which is a 6. This means if there is an even number, definitely we're gonna have a lot of subarrays. Because for example, 6 is okay, 6 is 9, 6 is 7, or 6 is 7, 13, or 9, 6 is 7, 13. Yeah, so in total it's going to be 6. But what if we have an array like 7, 3, 5? Yeah, because inside there's no even numbers, so definitely odd times odd is going to be odd, and times another odd number is going to be odd. So this is going to be always be odd numbers, there's no even product. So the final return is going to be 0. Yeah. Now it seems if we find an even number, we have to count. Yeah. But how can we avoid the duplicate? Whether we're going to count from the left or from the right, or from the left and the right together. So we're going to have a definition. So this is similar like the dynamic programming, definition. So if we find a number, yeah, so for example, the first number is 9. So our definition is that for this number, how many subarrays which is add with this number 9? Definitely there's a 0, because 9 is an odd number. Now, it comes to 6. So how many subarrays which the product is even, and just add with this index. So we have two numbers, it's going to be 9, 6, and 6, because 9 times 6 is even, and 6 is also even. Yeah. Now let's just go to the next. So this is even. For if it is even, it is okay. It means how many numbers? Yeah, it means we have two numbers, 9 and 6, and the index is 1. Yeah, so the first index is 0, and this index is 1. So currently we have two numbers. Yeah. So what if this is odd? So if it is odd, how are we gonna count it? We're gonna still have two numbers, because if we put an odd number here, it will make no difference, but we need to count it, because for 7, 6 it is okay, 7, 6, 9 it is okay, so it's gonna be 2 plus 2. So what about if we have another odd number, which is 13? So we're gonna still plus 2. It is just the similar idea. Because 7, it doesn't matter, because it is odd number. 7 and 13, it is still odd number. So what matters is that this is 13 plus gonna combine with 7 and 6. This is 1, and 13 gonna combine 7, 6, and 9. This is another one. So it's gonna be 2 plus 2 plus 2, which is gonna be 6. So in total, it's gonna have 6 subarrays. Yeah. So what if we find another even number? So for example, last one we're gonna have 8. Yeah, so we just need to combine them together. So the index for this 8 is 4. So how many numbers? 4 plus 1 is going to be 5. So finally, it's going to be 6 plus 5. Because for this 8, definitely it is even. So we're going to count this one to 13, this one to 13 to 7, this one to 6, this one to until to 9. So in total, there's going to be another 5 number. Yeah, because this is even, we need to count all of them. So if it is odd, we need to count the previous ones. So in this way, we can solve the problem easily by using the dynamic programming idea. Yeah. Now how we gonna do it? We're gonna use maybe let me define the length of the nums, and we need to find the last even index. I'm gonna set a -1 from the beginning, and I'm gonna have a final result. Yeah. So for I in range n, and we want to check this number. Yeah, so if nums I, yeah, let me do it in this way, maybe. Yeah, let's just do it like this. So if nums I modular 2 equal to 0, so this means this is an even number. Yeah, so if it is even number, what are we gonna do? So for example, if we find this is a 6 and it is an even number, so we need to update the result, gonna plus equal if it is even number, we need to update the last even index. Let's do it like this. So the last even index is gonna be gonna be I. Yeah, and this result gonna plus equal to the last even index gonna plus 1. Yeah, because for example, in this example, the 6 is index is 1 because we're gonna have two numbers. Actually, index 1 it means two numbers, so this is why we're gonna plus 1. Yeah. But else, we don't need to use else. I think this is okay. Yeah, because for the next one, for example, if it is 7, yeah, if let me do it like this. Yeah, if it is an odd number, else this means it is an odd number. If it is an odd number, we're gonna just result plus the last even index and plus 1. If it is even index, we're gonna update it. Yeah, let me do it like this. And we also need to check the last even index. It's gonna be more than 0. More than and equal to 0. Finally, we're gonna return the result. Yeah. So from the beginning, this is 9. Because the last even index is -1, so we will not count it. And then it is 6, so we're gonna count it. So the last even index gonna update it with 1. Yeah, but we're gonna count it because currently this is 1, and the last even index is more than 0, more than equal to 0. So we're gonna update the result. So the result gonna be 2. Yeah, and for the next, it is 7, but the last index already becomes 1, and we're gonna just update the result and update the result until we get the final answer. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works and it's pretty fast. I know the coding is just so short, but the idea is basically the dynamic programming idea. We just need some mathematics skills to analyze how to solve the problem. Yeah. Basically, like this example, if it is odd, it doesn't matter. But if it is even, it is 6, we're gonna count it. And for the next one, because for the last even index, it is already more than equal to 0. It means we've already found 1. So definitely we're gonna use the previous experience for calculating the odd one. If it is even, we're gonna update it and we're gonna calculate it. Yeah, I think that's all about it. Thanks for watching. See you next time.